Hello, ladies and gentlemen. Today we're going to be talking about slope, relationships, and graphs. So we're starting a new unit with coordinate geometry and quadrilaterals and how those two things are going to be like a checks and balances on each other. So we're going to be introducing geometry on a coordinate plane, which we've seen partially throughout the year, but it's easiest to understand when we talk about quadrilaterals in order to figure out properties of quadrilaterals, how to solve problems with quadrilaterals, and it's just a nice way to blend the two concepts or ideas. So before we get into all the quadrilateral stuff, when we move to a coordinate plane, we're going to have to review some Algebra 1 topics. So today the topics that we're going to review from Algebra 1 are slope, the relationship between slopes and lines, and then graphing those lines and slopes. So what you're going to need is maybe a calculator if you don't want to do some mental math, a pen or a pencil, and your notes. Yes, you are going to need to write this down. With that, let's get started. All right, the first thing we're going to talk about today is slope, or steepness of an incline of a line or a road. So in a real life situation, when we talk about slope, we're talking about like a lot of skiers know what slope is because you're talking about that side of the mountain that you're skiing down, right? Or the steepness of a road if your car's trying to make it up a hill, right? So steepness, if it's steep or not. So how we recognize slope algebraically or with an equation is we've always called slope the variable m. And we've called m equal to the rise over the run. So if you're looking at a graph with a line, and if you want to figure out the slope, we find it using that formula, rise over run. And if we've been given 2 points or 2 ordered pairs and we don't have a picture of what that graph looks like, then we can find the slope doing the y minus y values of those ordered pairs over the x minus x values of those ordered pairs. Or what some people say is the change in y over the change in x. This little triangle is delta, which means change in y over change in x, because if we're rising before we're running, you have to get up before you go for a run off of the couch. Anyway, at least that's just me. Maybe that's not you, but I know if I have to motivate myself to run, I'm getting up from something that I'm sitting on. So anyway, change in y over change in x. And then last but not least, if we want to graph the slope, we're going to need to graph a line. And whenever we graph a line, we use the form y is equal to mx plus b, where m is my slope and b is the intercept of the y-intercept. All right, so let's look at a quick example. If we just want to find the slope of the line from this graph. So if you're wanting to find the slope of the line, you want to find a convenient point or an ordered pair, or when we talk about finding 2 ordered pairs to count from the slope, an ordered pair is a point that meets on this grid paper. So for instance, if we look at this point that red line is crossing, it's not on one of these points that the grid lines is crossing. So in order to find an ordered pair on the line, we're going to need to find like this one. Here, I'll do it in a different color. I'll do it in red. So like -3, comma, -2. That's an ordered pair on the line. And then the next one that's probably crossing is 2, 1. So when we've been given a graph, when we find slope, we're going to use the rise over the run. And the rise is talking about my y's and the run is talking about my x's. So it doesn't matter if you start on the left point or the right point, but I'm going to start on the left point. So to get from the left point to the right point, I have to go up 1, 2, 3. So my rise is 3. And then to get to the right point, now I have to move right. 1, 2, 3, 4, 5. So I'm rising 3 and running to the right 5. When we talk about slope, if you go up, that's a positive direction. If you go down, that's going to be negative. So if I would have went down 3, that would have been a negative 3 in my slope. If I go right, if I move right, that's a positive direction. And if I move left, that's a negative direction. So don't forget that when you're counting slope with rise and run. Alrighty, more slope facts that you probably know. A positive slope rises to the right. You guys, when we read graphs in math, we read them just like a book. So if we have a coordinate plane and we have a graph like this, we read it from left to right. So in this example, my red line would have a positive slope because from left to right, my line is rising or going up when I look from left to right. A negative slope is one that falls from left to right. See how if I move from the left to the right, it's falling or going down. And when I have a slope of 0, it's a horizontal line. So if I draw a horizontal line, I'm going left and right for forever, but I'm not rising anything. So that means that I have a slope of 0, or I'm going to have a 0 movement moving up and down over some number moving left and right, which is creating my horizontal line. And then, of course, a vertical line is undefined because we're moving up and down. So we're moving up and down, but we're not going left and right any, which means we have a 0 movement in the bottom, which becomes undefined, or is what's making it a vertical line. So these are just some slope facts that you probably remember from Algebra 1, and if you didn't, then this is news to you. Alrighty, find the slope of each line and then figure out which lines are parallel. So we've been given a graph, so we're going to use rise over run. So from the left, I always work left to right. So from the left point on line A, this is line A, I'll do it in red. My slope, I'm going to go down 1, so that's a negative 1 for my rise, and then to the right, 1, 2, 3, 4, and I'll do line B in blue. My slope, when I go from this point, I'm going down 1, which is a negative 1, over moving right, 1, 2, 3. And then I'll do line C in green. My slope is going to be down 1, so a negative 1 for my rise, moving to the right, 3. So the question is, which of these lines are parallel? Well, if you don't remember, parallel lines have the same slopes. Parallel lines have the same slopes. So between my lines A, B, and C, which two have the same slopes? Well, line B and line C. So which lines are parallel? Line B is parallel to line C. Alrighty, now we want to find the slope of two lines that go through the following points. So now we haven't been given a graph of what these equations look like, but we've been given 2 points. So we're going to use the equation y minus y over x minus x. Now you guys, it actually doesn't matter which one's y2, just as long as if you do this y minus this y, so 6 minus 3. When you do x, you do this 2 minus 6, so it's going to be 2 minus 6. So even if you did 6 minus 3 over 2 minus 6, or if you did 3 minus 6 over 6 minus 2, you'll get the same answer. It doesn't matter which order pair you pick as order pair 1 and which one you pick as order pair 2. I just always work left to right, so that's what you'll probably get used to doing when you follow me. Okay, in my numerator, 6 minus 3 is 3, 2 minus 6 is negative 4. I can't simplify that anymore. Now for line 2, I'll do him in blue. We're going to do y minus y all over x minus x. So we have 3, positive 3 minus 7 all over 1 minus 4. 3 minus 7 is a negative 4, and 1 minus 4 is a negative 3, which changes that to a positive 4/3, because we know negatives, two negatives getting divided turns to a positive. So the question is, if we find these two slopes and if we graph them, we're trying to figure out if those lines are parallel. Well, they're not parallel, but another fact about slopes is that perpendicular slopes have opposite reciprocals. Reciprocals. Okay? So when we say opposite reciprocals, when we say opposite, we're talking about the sign, like the sign on the number. Is it positive or is it negative? And when we talk about reciprocals, we're talking about the number itself. So in these two lines that we have graphed, so for the slopes of these two lines, we're talking about 3/4, 3 over negative 4 and 4 over 3. So they have opposite signs because this red line is negative and the blue line is positive, and then 3/4 and 4/3 are reciprocal numbers. So in order for two lines to be perpendicular, they have to have both. They have to have both. They have to have an opposite sign and a reciprocal number in order for them to be parallel. Otherwise they are perpendicular, excuse me. Otherwise they will not be perpendicular. They have to have both. So make sure you get this in your notes because that's something that people typically mess up on. You have to have both, not just one in order for them to be perpendicular. Alrighty, let's go through another example. We need to figure out if these lines are parallel, perpendicular, or neither, and we're going to have to find the slopes in order to figure that out. So for line 1, which I'll do in red, my slope is going to be 4 minus 1 over a negative 3 minus 3. So 4 minus 1 is 3, a negative 3 minus 3 is a negative 6, which becomes a negative 1/2. And if I do line 2 in blue, my slope is going to be 1 minus a negative 7 all over 6 minus 2. You guys, when we take a minus a negative, that turns to a positive. So my top becomes 1 plus 7, which is 8, all over 6 minus 2, which is 4, which is 2. So we have to figure out, are the two slopes parallel, perpendicular, or neither? Well, parallel would tell me that they're the same. Well, negative 1/2 is not the same as 2. Perpendicular slopes would tell me that they have opposite signs. Well, one of them's negative, one of them's positive. So far, so good. And they also have reciprocal numbers. Well, 1/2 is the reciprocal of 2. So these two slopes are perpendicular. And then last but not least, let's talk about how to graph a line. When we graph lines, we use the equation y is equal to mx plus b, where m is your slope, rise over run, and b is your y-intercept, okay, or where it's crossing that y-axis. So currently, my equation is 2x plus 3y is equal to 12. Well, that does not look like this form right here. We need to figure out how to get it to that form, and how we're going to do that is solve for y. We have to get y all by himself. So in order to do that, we have to do reverse PEMDAS, which means subtract the 2x away. That leaves me with 3y on the right-hand side. Now, 12 and negative 2x are not like terms, so we cannot combine them. But if I want to follow the format of y equals mx plus b, I'm going to want to write the x number first. So you can write 12 minus 2x or negative 2x plus 12, but just know that the form asks for mx plus b, or that x variable, first, okay? And now in order to get y alone, we have to divide by 3. So you're dividing everything by 3. 3 divided by 3 is 1, so that leaves me with y. A negative 2/3, I'm just going to leave it like that. And then 12 divided by 3 is a positive 4. So when we go to graphing this guy, we want to graph 4 first. That's my y-intercept. So on the y-axis, I want to plot the point 4 on the y-axis. So at the value of 4 on the y-axis, I'm plotting a dot. From there, I'm going to use my slope, or my rise over run. So that means I'm going down 2 to the right 3. I can also be going up 2 and to the left 3. Down 2 and to the right 3. And so that is how we write the equation of a line and how we graph the equation of a line. I want to thank you all for taking such good notes, and I shall see you soon.